Hello everyone, I hope you are doing well. So the purpose of this video is to discuss your lab 4 types of reactions, main things you're doing in this lab, some tips that may help you, um, and to discuss, what overall I'm looking for in this lab whenever you complete it. So, as always, I start with the objective. So, in this lab, you are learning or reviewing the types of chemical reactions, and you're actually going to conduct a precipitation reaction. And from there, examine the data you collect to determine a limiting reactant. So, um, you've already studied types of reactions in lecture, and you studied how precipitation reactions, for example, are a type of double displacement. So this should be hopefully review at this point. And you've also visited stoichiometry, and you learned a little bit about stoichiometry, or a lot. um, but determining a limiting reactant is really important in stoichiometry, and you'll be revisiting that here. So part 1 shows you all about, or it reviews all about types of reactions. So how to notice physically when a chemical reaction is occurring, what single displacement reactions are versus double displacement. Notice that it gives you examples. These examples are very useful. The one that I really want to point out is this example 4.2. This will really, really be useful to you when you are completing the data collection portion. Because what do you know? It's about precipitation reactions, and that's what you're doing in part 2. So I'm not going to go into the nitty gritty of all these types of reactions. Please read through the intro, highlight things that you think are important, things that you maybe forgot here and there, or that you needed to brush up on when you learn this in lecture. I don't have the intro here, just to make the file long. I have it here as a really condensed review of exactly what the background information is for the lab. So please take time and read through it. Okay, so I scrolled through all the intro, and now I'm finally here at the procedure. So part 1, for the types of reactions portion, it's very self-guided, very exploratory. For this exercise, you will use online resources, Khan Academy, they have the website and also the YouTube videos. There is your OpenStax textbook. There's so many really good resources online. Really good YouTube channels, Melissa Maribel, the Organic Chemistry Tutor, the Khan Academy videos, of course. So many different ones. Obviously my videos, but my videos, I only have so many versus Khan Academy has a ton and longer examples in their videos, or just more examples, like a lot. So just visit all of those resources. And the whole point of visiting those resources and looking through those resources is to use that information or those resources to predict products and write basically balanced equations. From there, for the ones that are current solution, the ones that are aqueous, you will write the ionic equation and the net. And finally, you will determine the type of reaction for every single reaction. Okay, so that's what you're going to fill out in your data collection table 1. Okay, so that's part 1. Like I said, very exploratory, very much independent, and that's okay, right? Part 2, we're going a little bit more step by step. We're visiting this Chem Collective lab. That's the link right there. And this is what should show when you open that lab up. So I want to point out first the main functions that you'll be using in this lab. So let me try to zoom in. Yeah. So for example, when all I did was I clicked on this NaCl solution here. When I brought that over to the workbench, you'll notice that it automatically took me to this information tab. So this information tab gives you the name, the volume, the the components of this solution and their molarity. Notice that you can change, and I'm having a little bit of trouble. Usually it lets you toggle through grams and molarity. Guess it doesn't want to today. Let's see. Wow. There we go. So you got to play around with it. It's a little picky sometimes, but you can go through grams. You can go to, yeah, it's giving me problems. But anyway, it should let you. Just gotta, yeah, it's just a little bit angry. But the important thing that I wanted to point out was this information tab. It lets you go and figure out the molarity and also the grams inside of a certain solution that you happen to be on. So notice how it changed, right? But anyway, that's important, knowing that this information tab contains the information, what do you know, that you're going to record. So, and also knowing that you can toggle between molarity versus grams, okay? The other important piece of information is knowing how to mix solutions. So here I'm just doing something random. This isn't what you're doing in the lab. I just want to show you how you are able to mix or add one, either a powder, so either a solid, or a solution to another solution. Basically from one container, one glassware container to another. That's what I'm showing you. That's what I'm reminding you about. So all you have to do is grab one of them, hover it over the other. It's gonna show you that little box around it, dash box, and then it shows you, okay, it's pouring. So you're gonna do that for whatever it is you're doing, because you will have to do this type of transfer in this lab. So those are the two main things I wanted to point out to you. Of course, if you need a refresher on how to use the virtual lab, there's always information here. You can visit the help, everything. So that's the virtual lab we're using. Now back to our procedure. So some things I want to point out here on the procedure is that there's 3 parts, right? And these 3 parts, they give you a lot of sub steps. But what I want to point out and what I want to talk to you about is how step 1 and 2, all you're doing is confirming / determining masses or amounts. It can be, right, the mass or the molarity, but all you're doing is really recording information or recording data from the information tabs. Okay, you haven't done a thing, you haven't mixed anything, you haven't started a reaction yet, right? Remember, a reaction happens when, you have to have something mixed together in order to have a reaction happen, right? So this, step 1 and 2, and all their sub-steps are before the reaction has happened. In step 3, you are beginning the reaction. And then at the end is after the reaction, essentially. And the reason I'm emphasizing this and being so obnoxious about it is to really point that out to you and drive that home to you. And you'll see right now when we go to part 2 right here in the data collection. Okay, back to part 1 for data collection. You are writing out the balanced chemical equations, you're predicting the products, and you're writing out the net ionic, and you're also going to determine what the type of reaction is. So you're going to show me all of that in each little section for each reaction. And like I said, use all the resources you need. The book, the textbook, my slides, Khan Academy, all the YouTube channels that are really good, Melissa Maribel, the Khan Academy videos, of course. There's also the Khan Academy website. That's what I was talking about earlier. The organic chemistry tutor, so many, okay? I'm going to use all that. Yeah, you have a lot of them to practice. Okay, so now part 2. This is what I was really trying to point out. Table 2 is for the masses and concentrations before the reaction happens, okay? Before the reaction. So step 1 and 2. And then table 3 is after the reaction happens. So that very last step. That's the information that you're recording here, after that last step. Now from there, you're doing some follow-up work. So you're determining which one was the limiting reactant. Um, you're writing out the precipitation reaction overall, the molecular complete ionic net, labeling the spectator. You're doing that here. And then from there, you're determining the limiting reactant. Now, major hint that I really want to point out and emphasize in this video, to determine the limiting reactant, sorry, whenever I stumble, I just get tongue-tied sometimes. But anyway, for the hint, to determine the limiting reactant, I really want you to look at the masses or molarities. You can look at both. And what you're going to notice is that after the reaction happens, one of these 4 ions is very, very low. Basically, it got all used up. And I'll let you kind of tie that together with, determining which one the limiting reactant is. But that's what this hint is for. Okay, so don't ignore that. Don't speed through it. Hopefully it'll help you determine that limiting reactant. And then you just provide a 2 to 3 sentence answer to explain that. Okay, so finally we're here at the end. For these applied exercises, what you're doing is first you are completing some calculations, okay? And those calculations have to do with this problem that I listed out. So this solution contains 2 grams of sodium chloride. How many grams of silver nitrate must be added to completely react sodium chloride? So what you have to do here is know what reaction is happening. And the reaction that's happening is in your intro, part 2 section. So I'll let you visit that. It's already balanced, but basically you're doing some stoichiometry. You're doing some stoichiometry to get to go from grams of sodium chloride to grams of product. I'm sorry, from sodium chloride to grams of your other reactant. So these are both reactants, sodium chloride and silver nitrate. And in order to determine how much you need to add of this silver nitrate to completely react that NaCl, you need to do stoichiometry. So I'll leave it at that. But once you're done showing me those calculations, what you're going to do is confirm that amount that you get at the end by adding that to your solution 1 in your virtual lab. And you will screenshot that result. So to screenshot, you can either do Control-Alt print screen and just copy and paste, or you can open this little program on Windows called Snip and Sketch. I know Mac users might be hating me right now. I'm sorry, I don't know how that's done on a Mac. I'm not a Mac desktop user. I use my iPad and my iPhone, but fortunately not a Mac desktop user, so I'm sorry about that. But I know there's how-tos everywhere on Google, on YouTube, so look there. If you can't find one, I'll try to find one for you. But anyway, you can either show me your whole screen, or you can do a little snip and sketch, and basically it lets you choose what part of the screen that you want to take a screenshot of. And then from there, you'll paste it here. And you're going to essentially do the exact same process, but for a second problem. So there's 2 different problems here, right? The second problem, you are using solution 2, and it contains 3 grams of silver nitrate. So if I add excess NaCl, which is the other reactant, right? We're kind of going backwards here. Here we're starting off with the other reactant, which is AgNO3 silver nitrate, and then we have excess NaCl. We're trying to see how much product is formed. So here you're going from the reactant to the product. So again, stoichiometry involved there. So you're going to do those calculations, that dimensional analysis, and then you are going to do the same thing. You're going to go back to the virtual lab. You're going to add that amount you calculated, and then you are going to see how much AgCl formed, and see if that amount matched. Sorry, I spoke earlier. NaCl doesn't matter how much you add, you can add excess. What matters is how much AgCl formed for this particular problem. Okay, so you're going to look at the information tab, see how much AgCl was formed. It should match what you calculated here. Okay, so that's the extent of this lab. As always, thank you for watching. Thank you for listening to me stumble here and there. And let me know if you have any questions.